Okay, so it's Wednesday afternoon, and as you can see, I'm outside enjoying this beautiful day and thought we might discuss slope and lines. So, when we're dealing with linear functions and we're talking about the graphs of linear functions, we are interested in some criteria that will allow us to define these functions in a more specific way. In particular, we want to know about the slope of lines, and often when we have, well, always when we have a slope and a point, we can define a line specifically. So there are a few formulas that you need to know, and when I say know, I mean know. It's in your head. We don't have to look at note cards. We just know these things. So we're going to start with, what is the slope of a line that passes through 2 points? Well, let's say that I have points x1, y1 and x2, y2. So if I want to find the slope of a line passing through these 2 points, what I want to do is plug it into this formula. M is equal to y2 minus y1 over x2 minus x1. Now notice that we have the difference in the y's on the top and the difference on the x's on the bottom. Often students will flip that around and put the x's on top. We don't want to see that. We want to see the rise, or the difference in the height of those points, over the run, or the difference in the vertical distance. Okay, so this is something you definitely need to know. We're going to apply this in a little bit. Another thing that you need to know would be how to use point-slope form of a line. So point-slope form of a line is a really useful formula, and we don't see it so much in high school because when you have a line, there are an infinite number of points on a line. And if I were to use point-slope form of a line, I might have an infinite number of answers, which makes things a little bit more tricky when you're grading lots of paper. So we often fall back to slope-intercept form, which we'll see in a minute. But point-slope form of a line is really, really useful because we can substitute any point that falls on the line and the slope of the line and come up with the equation of the line, which is really nice. So if I'm looking for point-slope form of a line, then we write it like this. If it's going through x1, y1, and it has m as a slope, point-slope form will be y minus y1 is equal to m times x minus x1. And we can easily convert that to slope-intercept form if we want to by distributing the slope through on the right-hand side and then just shifting that y1 over to the right-hand side. Okay, so that's a nice thing to know. Then I alluded to before, what is slope-intercept form of a line? Slope-intercept form of a line is what you're most commonly using in your high school experience. And since a linear function, with the exception of vertical lines, since a linear function will only pass through your y-axis once, it is a unique point for this line. So we can use slope-intercept form to easily identify a line that passes through the y-intercept, which is b, and slope m, y is equal to mx plus b. Very nice. Okay, so next we'll talk about what is a general form of the equation for a linear function. And we do use this on occasion. The handy thing about this formula is it can be used for all lines. Horizontal lines, vertical lines, lines with any kind of slope. General form of a line is everything to one side of the equal sign, ax plus by plus C is equal to 0. We usually put the stipulation that A must be a positive value, and A, B, and C are usually considered to be integers. All right, so that's a handy thing to know. Now, we want to know what the equations of vertical and horizontal lines look like. They are a little bit different because they don't have all the variables in them because of their unique functions, or I'm sorry, their unique attributes of being purely horizontal or purely vertical. A vertical line will be in the form of x is equal to c, and that c can be any constant. It can be positive, negative, fractional, anything that's a real number will make this a vertical line. Now this will pass through, if it's a vertical line, it's going to pass through the x-axis at that c value. So for instance, x equals negative 3 will pass through the x-axis at negative 3. Now likewise, horizontal lines, y equals c, y is equal to any constant, they're going to pass through the y-axis at some value c. And that c, again, can be anything, any real value, positive, negative, fraction, decimal, anything. You name it. If it is a real number, then we have a horizontal line. All right, so last formula that we're going to look at, and then we're going to apply your slope formula. The average rate of change formula. Now this looks pretty similar to slope formula, and in fact it is related. The average rate of change formula calculates the average change of any function from one x value to another x value. Okay, so let's say that I'm interested in this function here, this quadratic function. All right, I'm going to move over here. Quadratic function, and I'm interested in the average rate of change from x equals 0 to x equals, let's see, what did I put on there? 1, 2, looks like 3. X equals 3. Okay, well then what I'm really calculating is what is the slope of the line connecting those 2 points. Okay, so what we do is we substitute the x values in and get y values out for the top, x2 minus f of x2 minus f of x1 on the top, and then x2 minus x1 on the bottom. Okay, so it is the slope of the line connecting those 2 points, but those 2 points can reside on any type of function. All right, so now we're going to talk, oh look, the sun just came out. It's a little bit bright. We're going to continue and talk about how to apply the slope formula. So let's say I've got 2 points and I am interested in finding the slope of the line that passes through those 2 points. Well, then I use that slope formula that I discussed earlier. M is equal to y2 minus y1 divided by x2 minus x1. Okay, so let's look at this example here. Let's look at the idea, I can't really see because of the sun, that I'm interested in the slope of the line that passes through the points negative 3, 4, and negative 4, negative 2. Well, then I'm going to substitute those points into the slope formula. And it doesn't matter which one is x1, y1 and x2, y2. They're interchangeable as long as you keep the x1 over the y1 and the x2 over the y2. Notice that the negative 2 and the negative 4 both come from the same point, and the negative 4 and the 4 and the negative 3 come from the same point. As long as they're over top of each other, it doesn't matter which one comes first. So if I substitute that into my formula, I get negative 2 minus 4 divided by negative 4 minus negative 3. Okay, and then when I simplify the top, I get -6, and when I simplify the bottom, I get -1, and I have -6 divided by -1, or a slope of 6. Okay, now anytime you have a positive slope, that means that the line is rising from left to right. It's increasing. Okay, so keep that in mind. Anytime your slope is positive, you have a line that's increasing. All right, now if we move on to the second example, I have points 4, -1, and -1, 5, which when I substitute it into the formula, I have 5 minus -1 divided by -1 minus 4, simplifies to 6 over -5, or in other words, -6/5. So in this case, we are falling 6 units for every 5 units that we go to the right. Okay, so we are falling 6 for every 5 units to the right. In other words, we are decreasing, or sometimes my math lab will use the terminology falling, rising, horizontal, vertical. This is a falling function. In other words, it's a decreasing function. Okay, last two of these and then we'll call it good. This example, we have 2 points, 5, -3, and -2, -3. And when I substitute this into my slope formula, something kind of funny happens. -3 minus -3 divided by -2 minus 5. Well, that -3 minus -3, that's a -3 plus 3. In other words, a 0, okay? A 0 over any value is 0. In other words, there is 0 rise, but we are running, okay? So if we're not rising, but we're running, this ends up being a horizontal line, okay? A horizontal line. Now, you can kind of see that if you look at these points, the coordinates of the points. Notice that your y value is exactly the same, -3, -3. So on the left side of the y-axis, we're down at -3. On the right side of the axis, we're down at -3. And if I connect those points, a horizontal line. All right, now, last one of these. I have 12, -1, and 12, 7. Okay, so if I substitute these values into that slope formula, 7 minus -1 over 12 minus 12. And this time when we simplify this all up, I get some value, or in this case 8, over 0. Now, we may or may not remember that we are not allowed to divide by 0. This is actually considered an undefined slope when we have a 0 in the denominator. This is a rise but no run. A rise but no run. That means we have a vertical line happening. Okay, and again, look, we have an x value of 12, x value of 12. All of this is on the right side of the y-axis at x equals 12. And if I connect any 2 points where x is equal to 12, I have a vertical line. All right, hope you enjoyed talking about slope and linear functions, and we'll pick up the rest of this in class next time we meet.